Well, hello there, everyone. Everyone just waiting here in the spaces for us to kick off. Such a pleasure to have you all here with us again for the next installment in our A and B Spaces series. Today, we are not going to disappoint. We have the co-founder from Celer here with us. So we're really looking forward to today's spaces. I just want to say that the last few weeks have been absolutely incredible. Just having different protocols in the A and B space hop on. So if you've been enjoying this, and I hope you have been, as I have been, why don't you just share this, retweet this, so that others can in as well. Right now, I'm just welcoming the host with the most, Mark, onto stage, and we'll begin shortly. Hey there, Arjun. How you doing? Hey, Mark.
Hey, how's my audio?
Audio is Gucci. It's sounding as good as can be.
Hey guys, Mo from here, Celer here.
Hi there, Mo. Welcome, welcome. It's such an honor for us just to have you here with us. I was actually looking for your personal account. It's really great to see you with that account. Um, really looking forward to kicking this conversation off with you. Co-founder from Celer, started off in 2018, and we know you just have a rich industry, just leading multiple engineering teams, being product manager, and we're just excited to hear more about Celer, more about your background. So welcome everyone from the Celer community, from the LI.F I community. Let's kick this off. I'm going to hand this over to Arjun and Mark, and they'll kick this conversation off for us. So over to you.
Hey, yeah. So this is, I think, the fourth version of our Arbitrary Messaging Bridges Twitter Spaces.
That's right.
We're super excited to have Mo on and talk about Celer IM. Chat about how maybe a transaction lifecycle looks on the network. We can talk about trust assumptions, which is Arjun's favorite thing to talk about, and of course, we can just talk about what's being built on top of Celer IM at the end of this. But just to give a little bit of background on the AMB Twitter Spaces, Arjun and I published a piece on that was titled "Navigating Arbitrary Messaging Bridges" about a month ago, which broke down 7 of the largest arbitrary messaging bridges, which Celer IM is. As the name suggests, an arbitrary messaging bridge allows for any piece of data to be moved from chain A to chain B. So in addition to tokens, which is what a lot of people think about bridges when they think about bridges, they're like, oh, move tokens from chain A to chain B. A and Bs make it possible to move complex data like the state of a chain, a contract call, an NFT, a governance vote across chains. And we are super excited to learn more about how Celer IM works. With that, Mo, I'm going to pass this over to you because the first question in every single Twitter Spaces is the same. It is, well, what is Celer IM?
Yeah, absolutely. Thanks for the invite. It's been great pleasure working with you guys. First of all, in the bridging aggregator space, and I myself use LI.Fi daily actually. What is Celer IM? Celer IM is Celer Network's interoperability solution. It's a generalized cross-chain message protocol where you can essentially send any arbitrary message from one to another in a very secure way. Now, if we're looking at a generalized message passing protocol from any provider, it basically consists of 2 parts. One is that you have these on-chain contracts that are essentially interacting with the on-chain apps. And there are the applications information receiver, and then we can kind of, I guess we can kind of dig into the technical details later. But just from a very high level first, there are a bunch of applications built on top of the Celer IM today already. For example, the most notable as the C bridge, which has processed over $11 billion transaction volume in the last year, which is the asset bridge that connected 35 different chains and served about 200K users by now. And also there are various other interesting application solutions that build using the generalized cross-chain message passing protocol. Most recently, PancakeSwap launched their Ethereum expansion and also used the Celer's cross-chain message to enable a cross-chain reward claim for the cake token on BSC chain. So but there are a lot more use cases, but this is just a very, very high-level introduction. We have about 5 different apps and application scenarios being built or already launched on the Celer IM platform, and there are a lot more in the testnet phase at this stage.
Yeah, and Celer IM, is it live on 12 chains now? Is that number correct?
Yeah, that is a correct number.
I believe those are all EVM compatible too, if anyone is keeping track at home. Okay, so that is the high-level explanation of Celer IM. What we like to do here in these AMB Twitter spaces is get a little bit into the nitty-gritty. And so I'd love to kind of talk about what a transaction life cycle looks like through Celer IM. And by my estimation, there are 4 different players that we should chat about within this life cycle. You have the dApp plugin, which is kind of what the end user interacts with. You have the message buses, which relay the information that you're moving across chains. You have the state guardian network, which is where the Celer token comes into play. And then you have the executors or executors. Not sure what the right way is to pronounce that, but that is kind of what moves data onto the destination chain. So would love for you to just give us maybe a deeper dive into what a cross-chain transaction might look like going through Celer IM.
Sure. Yeah. I mean, like a cross-chain DEX is a really good example for cross-chain, bridge, essentially life cycles, message life cycles. So, in general, there are a few components that you mentioned. The first is that the user is going to be interacting with, let's say, one blockchain directly, right? So they will be interacting with a dApp contract on, let's say, Avalanche. And on Avalanche, when they're interacting with the dApp contract and also a backend server, they essentially are interacting so that they express their intent to say, okay, I'm going to want to swap my AVAX token on Avalanche, BNB token on Binance chain. And how that works is that they will send their AVAX token into a dApp plugin, essentially, or this kind of a wrapper contract that will first try to swap the AVAX token into certain stable tokens that is bridgeable, because it's not every token has the bridge liquidity today. Most bridge liquidity concentrates on USDC, USDT, and wrapped Ethereum. So the first step is to actually convert token to something that is bridgeable. So this part is not involving any message passing. It's just a kind of a DEX aggregator or connecting to certain DEX. But after that, you basically got a bridgeable asset as a USDC, and then the USDC is going to be bridged across to the destination chain. In this case, in this example, it's BNB chain. But at the same time, there's also going to be a message passed alongside with that particular transaction or that particular asset bridge. Say, hey, when you actually receive this on the destination chain contract, when you receive this particular asset, you're going to do something about that. That something is the message. The message is going to be basically saying that, hey, execute this logic to swap the USDC to BNB chain using PancakeSwap on the BSC. So that's what the message say. And whenever the message arrives on the destination chain, the message will be executed, and then, essentially the cross-chain swap will be done. Now, the interesting part here for the entire life cycle, the most interesting part here is actually who the message deliver entity, basically, who is actually kind of syncing the message from the source chain and then delivering it to the destination chain with certain authority, right? So in Celer's case, this messenger, this message deliverer is basically called state guardian network. So it is actually a Cosmos-based blockchain itself that listens to all the events that is generated, on all the message bus contract on all the connected chains. Whenever there is an event, emitted, all the validators in the state guardian network, which is a Cosmos blockchain itself, will be able to hear this and reach consensus that this event actually happens. So the consensus is actually a Cosmos consensus where you basically have staking of the Celer token to become a part of the become a validator, and also you can delegate your token to certain validators. So it is providing the same level of security of Cosmos today or all Cosmos chains. So now the consensus is reached, there is also going to be a weighted signatures that are generated on Celer. This is a little bit different from some of the plain multi-sig solutions. It is not a M out of the N multi-sig, but it's actually weighted by the stakes that is in the blockchain itself. So it comes with economic security out of the door. And then, by default, you can just pass this message to the destination chain's message bus contract, and the message bus contract will call the destination chain's business logic contract to actually execute whatever the message is saying. Now, as you see, like the default security model for the Celer's cross-chain message framework is based on the Cosmos POS security, right? So like it's basically a proof of stakes blockchain, as long as there are less than 2/3 of the validators that are bad actors, the chain is secure. As long as there are less than 1/3 that are malicious, then the chain is live. Now, it bears the question that, okay, what happens? Let's the transaction itself, the blockchain itself that is delivering the message is actually becoming malicious, especially for some very, very critical messages, right? So, for example, if you're doing governance, cross-chain governance calls that are allocating certain cross-chain tokens, governance tokens, it's not very frequent, but it's super important. Or if you're doing cross-chain asset bridge, but the size is super, super big, like 100 million, 15 million in a single transaction, right? So how do you kind of ensure, even in the case of the total consensus failure of the middle chain, the entire cross-chain path or the cross-chain message path is still 100% secure? Now, that comes to our second security model that is built into Celer, which we call an optimistic roll-up-like security model. So the essence of that is basically whenever a message arrives on the destination chain, it is not immediately executed. Think of there is this kind of a quarantine box where first you have to put the cross-chain message into a quarantine box for a certain time. So in that time, the message is just there, sitting there. It cannot be executed. Nothing will happen on the destination chain. And then there are a bunch of application level, what we call app guardians, where let's say if you're running a bridge app or you're running a cross-chain governance app, you can build your own app guardian who is actually cross-checking the source chain data to see that if a destination chain message is actually matching whatever is emitted on the source chain. And this app guardian has the capability to cut off transactions in the quarantine box. Basically, oh no, I see this message is actually not exactly the same as the source chain emitted message. I'm going to cut off the message execution path, and then resort to kind of a dispute process to dispute the message, on the source chain. So, but what it does incur is an additional delay in the message passing process, because you're essentially doing a two-phase commit protocol for the message delivery. You first commit the message on the source destination chain, and after a certain mandatory delay, the message is actually going to be executed. So, this pattern we have found out. This pattern has been extraordinarily useful, and this is actually used in Celer C bridge today, where if you're sending out if you're bridging a value larger than a certain threshold, this kind of two-phase commit model will be automatically kicked in, so that this has kind of an additional security level. This enhances the entire security level from the POS security to trust any. As long as there is still any live app guardians that are watching the source chain state, then this entire message passing process is secure. So yeah, I guess this is just a kind of a quick overview of the critical pieces here. But yeah, happy to kind of delve into more on the security side, especially on the operational security as well.
That was not quick. That was very detailed, and it had a lot of information. So thank you for that. Maybe you could, dive deep into different elements that you mentioned there. So starting with the SGN network, we have some follow-up questions. So maybe you could explain to us why you chose Cosmos first of all, and how do you it's decentralized? Because I think right now it has 21 validators, and you've chosen a weighted by stake mechanism. So maybe explain the thinking behind that.
Sure. So first of all, the Cosmos blockchain itself, right? So like, why did we choose Cosmos blockchain in the first place? Cosmos blockchain, this history involving how we the Celer project initially was focusing on state channel technology, which is a layer 2 scaling technology that is speed up payment transactions. It's a kind of a Lightning network on Ethereum, but it's more than that. In the state channel construct, we had something called State Guardian Network that is monitoring the off-chain state and bringing it on-chain. So it is a natural transition for us, first of all, to transit from the state channel architecture, where we already have a live and secure state guardian network built and running for a couple of years, and transition and adding the functionality of cross-chain bridging and cross-chain message passing onto that layer. Now, Cosmos-based consensus has been running for a very long time. Polygon is running on Cosmos-based blockchain. There are entire Cosmos ecosystem there. So in terms of the software stack, it's very stable, and in terms of the flexibility, it is also extremely flexible, because you can actually implement logic inside of the blockchain itself, right? So if you look at the entire landscape of cross-chain message passing, there are a lot of cross-chain message passing protocol where you can just pass message from chain A to chain B, and that's it. But what we are thinking in the long term is that you really need to have that middle chain where you can actually store states, and you can actually have application inside of the middle chain, where the application can receive message and operate and send message to destination chains, and also kind of a process message that pass by this blockchain. This is already happening today, actually. On Celer's application. For example, C-Bridge. C-Bridge has one model which is called liquidity pool-based bridging, where on both sides you're not doing this kind of a lock and minting process, but actually locking up liquidity pools. Let's say for Avalanche to Polygon's USDC bridge, you kind of need to have a liquidity pool locked up for both sides in the form of USDC token that is natively issued on each chain. There is this question to be solved, that is, how do you balance the pricing for the bridging, right? So let's say in one day Avalanche's USDC demand is just very high and everyone just bridges into Avalanche, and then the resulting fact is that the Avalanche side of the USDC pool is going to running dry. It's going to be running dry, and all the USDC is going to be concentrating on Polygon and all the other different chains. Now, how do we solve that? Well, the natural solution is to build a pricing curve. But to build a pricing curve, if you're just having the simple mechanism of message passing across chain, you either need to have AMM pairs on both sides of the chain, which incurs high cost on both sides, and also very low liquidity utilization on both sides as well. Or you have this complicated logic to kind of pass message back and forth between different chains. We saw this kind of a method for some of the other cross-chain bridges as well. But for Celer, the logic itself can be a part of the blockchain, can be part of the middle blockchain, or can be an application on top of the middle blockchain, because the middle blockchain has visibility of all the chain's states it connects to. So whenever a message actually passed by, hey, I want to bridge $100 of USDC from Polygon to Avalanche, the blockchain itself knows that, okay, the Avalanche side of the USDC is running dry, and therefore the pricing should be calculated based on the balance that is currently available on the Avalanche side of the chain, and the high balance that is currently available on Polygon. So it will immediately calculate a right price, essentially transform the message and pass the message on to the destination chain with the right pricing. So the benefit of this is that it significantly increases the liquidity efficiency for liquidity providers providing liquidity in the bridge, and also at the same time drastically lower the cost for users interacting with the smart contract on both sides.
Wow, you're giving all of the bridge interns who tuned into this podcast so much info today. Okay, but so something that we've found to be a trend in the A and B space is for bridges to sort of launch with their initial mechanism, which is usually an external validator set. In your case, it's SGN, but then to add a kind of fallback mechanism for security. So like we're seeing Layer 0 implement pre-crime. Last time we had Sergey on from Celer, he described a firewall concept. And now Celer IM has deployed an optimistic security module to kind of back up the SGN. Why did y'all decide to go with a fallback mechanism, and what led you to go the optimistic route?
Yeah, so I wouldn't say it's a fallback mechanism per se. So like it's really kind of a integral part of the entire bridging architecture, right? So I would say, like, if for any kind of computer science system design, the key thing here we should be talking about are trade-offs. Optimistic rollup enhances the security level to trust any, but at the same time, it has costs. The cost is a delay. The cost is the higher cost, in terms of per transaction cost, and so on and so forth. And for Cosmos-based solution, it's not something that is insecure, first of all, because there are a large number of blockchain today that are running safely, securely, holding billions, tens of billions of dollars BL that are based on Cosmos-based construct. And but basically the capability of a Cosmos-based blockchain is that it can also almost instantly pass message. So if you're transferring certain messages that simply don't care about latency, and you think latency is just not part of the trade-off equation, and you think that cost is not part of the trade-off equation, then this is the right time to kind of use a additional low level of security. So it's not one or the other. So when you're using optimistic rollup-based security, you're actually enhancing the POS security with the optimistic rollup. So it's kind of working together at the same exact time. It is not actually kind of a turning off the POS model, but switching to the optimistic model. So it's actually kind of running at the same time. And we are seeing this being built today and used by applications in concurrently, basically. For C-Bridge, as I mentioned, for smaller transactions, always goes to the PO. For larger transactions, it triggers an optimistic model. Now, for example, for pancake swaps use case, if it is for reward redeeming that is lower than a certain threshold, it goes to the POS. If it is higher than a certain threshold, it goes to the optimistic rollup path. And if it is for governance, more importantly, let's say if it is actually kind of trying to tune the total amount of reward allocated to Ethereum pool, it is actually going through a optimistic rollup based approach, and the developer themselves can actually time delay, right? So you can have a cross-chain function call, and the cross-chain function call can be put into quarantine zone for 24 hours if you want, to ensure a even higher level of security, because you have abundant of time, even considering any kind of disastrous downtime, to make sure that the cross-chain message actually passes secure. So these are, I would think, different kind of trade-offs that one need to play, and oftentimes even in a single app, you'll be using different kind of trade-off point. What we're trying to achieve here, essentially plot an entire trade-off plane, so that developers themselves can choose which kind of trade-off points that they want to operate and for what kind of use cases, even inside a single app. So this is like our position here, essentially. And in fact, optimistic approach is not the end of the line. In the future, we will add like zero knowledge based cross-chain solutions that has its own set of trade-offs as well. So it's really kind of expanding and providing all the available solutions out there, and let developers themselves to choose.
Expanding on the optimistic model, can you explain how the quarantine zone is that dependent on the chain, or can the dApps decide how long the quarantine zone is?
Yeah, absolutely. So, basically, the quarantine zone is also, a part of the application kind of adapter's logic. So, whenever a message is received on a destination chain, the application developer can basically filter that particular message to say, okay, if this is this kind of message, it has to be quarantined for a certain period of time. So, the quarantine time and quarantine delay is actually considered per application and per application use case. Let's say inside of a single application, you can have even different delays for different kind of message. You can have zero delays that is fully trusting POS blockchain security, or you can have like 24-hour 40 hour, 48 hour. If you want, you can have 7-day delays. That's totally developer's choice.
Beautiful. And has the Celer IM, have any Celer IM watchers successfully kind of pushed back against a malicious transaction? Because I know that happened on Rainbow Bridge, I think 2 or 3 times so far.
Yeah, Rainbow Bridge is a little bit different because Rainbow Bridge itself is a light client bridge, and you can actually try to push through malicious transactions relatively easily. But for Celer, unfortunately, well, actually, fortunately, no such issue has occurred. As I mentioned, the optimistic roll-up based solution is not mutually exclusive with the POS model. So when the optimistic roll-up passes the trigger, the POS is also working. If there is any kind of pushback of the message, it means that our POS pass has completely failed, which it hasn't. So that's I guess kind of a short answer for that.
And you also mentioned about adding ZK tech to your stack in the future. Can you give us more insight into that, or is that like too much alpha for the moment?
Yeah, it's probably a little bit more info than moment, but honestly, yeah, the we can see where the trend is going, and we have spent a lot of time researching the space. So yeah, zero knowledge has its own trade-offs and different kind of foes. We'll probably pick another time to kind of expand that more.
All right, we'll have to have you back on once we get to ZK bridges. I feel like that's going to be a whole nother research article, Arjun. That'll take months and months of our time. Okay, so kind of the next part, we're about halfway through here, is we always love to talk about the concept of trustlessness in the bridging space, because I think everyone who comes into crypto is usually orange pilled through Bitcoin, where like this idea of that Bill and Alice can send a transaction across the internet, and you don't really need a bank to do it. It's this trustless system that relies on validator sets to move asset A to from here to there. Now in the bridging space, we've kind of recreated this problem, because now instead of Alice and Bob, we have blockchain A and blockchain B. And how do you have them communicate in a trustless way? Meaning we're not adding any extra things on top of just validators. What do you guys think of the term trustless at Celer IM?
I think trustless here or trust free here basically means that you have a decentralized or distributed system construct that is not relying on any single entity and sufficiently decentralized, so it is not plausible to be kind of easily censored. So in Celer's case, it offers this criteria because Celer is run by a very distributed network validators, and just like many of the POS chains, it is fully decentralized, and there are a lot of users who can select and vote for different validators freely, and have validators kind of join and shifting different kind of voting powers into the bridge. So that's what we think as a trust-free construct or trustless construct. I think as long as a strong security model is in place, and it is not very easy to be kind of single-handedly censored, and that should be kind of categorized as trust-free.
Can you maybe expand on the role of validators? And I think right now SGN has 21 validators. So do you plan on adding more validators in the future, or how do you see the roadmap for decentralizing this set?
Yeah, so like we so first of all, 21 to 100 is where most of the POS chain sits today. So like one way to look at this is Celer. Currently, the state guardian network itself is very similar to all the existing POS networks, and the level of decentralization is in some cases actually bigger. But yeah, so in terms of the number of nodes, for Tendermint based consensus, it's easily expand to 100 each validators. For sure, and we'll kind of continue to add more validators into the space as well.
So can anyone become a validator, or are there specific requirements?
Well, in theory, anyone can become a validator, but for bridge validators is a little bit different from let's say a blockchain validator, because it kind of has a different set of requirement. You would need to have a very very reliable local full node for all the connected blockchains, or if you want to use hosted, that's also fine. But if let's say you miss the event, or having a wrong event signed, or kind of having any kind of RPC issues, then the result is basically facing the slashing of the stake for the particular validator. So a more different kind of requirement than running a single blockchain validator for sure.
Yeah, that's great for us to know and hear about from your side. So recently, we've seen a lot of teams sort of tie their token to grid security, right? So here we were just wondering, is the price of Celer tied to security as well?
Sorry, could you kind of repeat the question? I didn't quite get the question itself.
Yeah, sure. No worries. So recently, we've seen a lot of teams kind of tie their token to grid security, right? So we were wondering, is the price of Celer tied to security too?
Tie the security of the bridge to the token. Yeah. So for the POS model, as I mentioned, like because it's a proof of stake chain, the if you can somehow take over 2/3 of the voting power, in the entire seller's market cap, yeah. In theory, like just like any other proof of stake blockchain, it can have malicious takeover scenarios. But taking over a Cosmos-based POS chain is not that easy, because you cannot just fabricate any kind of transaction, because you still need to have transaction validity. There are certain type of a transaction that you can forge and fabricate it, and this is why there is a hybrid model there to further defense against any kind of malicious takeover of the cross chain message. But yeah, so like yeah, Celer's token is tied to the POS based cross chain message passing security, but at the same time, it is also a device for value capture, because all the transactions pass through cross chain message system also pass through the blockchain, and therefore pays fees for the cross-chain message processing to the validators and to the stakers of Celer token. This is how Celer token will capture value, and also how Celer token helps to secure the entire network. It's just very much the same as any proof of stake blockchain today, like Ethereum, like Avalanche, like any other proof of stake chains.
That's great to know. And I think building on security with bridges, we saw the BNB hack last week, and then there was the update from the Cosmos core team about how they patched a critical security vulnerability. So we're wondering if you have any views on security in bridges in general, and how does Cbridge view security, and what are the general security practices that you guys follow?
Yeah, for sure. So, I think security has, So like for bridging security, first of all, bridging security definitely has its own complexity. It's not a single chain contract. It's involving multiple different moving pieces and asynchronous communication systems at the same time, right? So bridging security, as the evidence has told us once and again, is hard. We have how many in total for the entire community about like $2 billion lost in all the other different kind of bridges, basically. So the way we're looking at bridge security in general, and in fact any kind of a system or computer system security, is that first of all, you should not rely on audits. Audits are good, like it helps to have audits for sure, and we have them, but you cannot really rely on them. There is a mentality in the space and in the entire kind of a community, basically saying that if my contract get audited, this should be fine. But what we would suggest, and we kind of practice what we preach here, is we should employ a method of what we call defensive coding, right? Basically, saying that do not think that your system don't have issues. Code and coding the entire system up as if there are some bug in the system, right? So, for example, we see in many cases for bridging system, a hacking transaction happened, and just one single transaction can steal the entire TVL of that bridge. So this would be an example of lacking of a defensive coding, right? So for example, there should be certain kind of delay factors. If it is a withdrawing large amount of even rate limiting or circuit breakers in place, at least in the early life cycle of bridging systems, to defense against any kind of possible flaws in the system. And this is what we practice as well. Now, nobody can say that the code that their team wrote can be free of bug forever, and we're certainly not claiming that. That's a too strong claim. Coming from a networking security background, I know, like, you know, uh, a lot of weird things can happen in the security space, but we believe that we should be relentlessly doing this kind of defensive design practice from day zero, basically, for all the system, for DeFi protocols and for bridging protocols. Now, one kind of a practice that people often do is to have a shadow watchtower, right? So basically, you have one system that is actually production running, and you have the second system that is independently written, but getting all the same input from the production system and replicating the logic and comparing the logic and comparing the results with the production system to cross-check whether there's anything wrong. So this is actually a very good practice that is employed by many financial sector application building practices, and we think there should be definitely be widely used by the blockchain community as well.
Yeah, and I think just so the people know, I think y'all have also, I know you said you can't rely directly on audits, but I believe you have been audited 3 times for Celer IM, and I think you have about a $2 million bounty with Immunify. Is that correct?
Yeah, that is correct. And we love a white hat community for sure, and we encourage anyone to look into the system and find any that seems off.
Perfect. Well, I think this is a good time to kind of segue away from the detailed conversation about security and kind of talk a bit more about where Celer IM sees itself in the bridging space. One thing that we ask every single bridge that comes up to the A and B spaces here at LI.F I is Mo, where do you see Celer IM sit in the A and B world? Do you see this kind of being a one bridge to rule them all type environment? Or do you think there's room for tons of different arbitrary messaging bridges?
So, first of all, I think the entire bridging space is very, very dynamic. There are a couple of application use cases that every A and B solution have seen: cross-chain governance, cross-chain indexes, cross-chain lending, cross-chain perps. And in those kind of spaces, you would probably find in the next like 3 to 6 months is every A and B bridging solution, including of course Celer. By every A and B, I guess I should say like every reputable A and B solutions will have an application built in that space which everyone sees. What's interesting is that we should all ask ourselves this question: whether message passing is actually the right primitive for cross-chain interoperability and multi-chain interaction, right? So, the cross-chain message passing mechanism is still very single-chain oriented. It assumes that the user will pick one chain and interact with that, and it just so happens that this particular chain has the cross-chain message passing functionality to interact with certain other contracts on the other chain. But if we look at the entire area of computer science development or computer development in general, we can draw an analogy here when we're kind of talking about multi-chain as a kind of a single CPU to kind of a multi-core CPU transition, right? So, but if we're looking at this, the of a single CPU to multi-CPU transition, we don't really kind of have this practice where a user will be interacting with just one CPU and kind of talk to all the other CPUs directly, having that level of exposure to the end user. The end user just use apps, and somehow the application's work is distributed to all the underlying processing unit. So for blockchains, it's a similar concept. Where we experienced an explosion of multi-chain, which is essentially bringing us to a parallel computing age for the entire blockchain ecosystem, either by multiple layer 2s or multiple alternative layer 1s other than Ethereum. So we are already there. The question is, how do we build a upper layer abstraction to allow users to better interact with all the apps in the space? This has everything to do with how we build account abstraction, which is a topic that talked a lot in DevCon recently, and whether we should be building a cross-chain account abstraction, or what we call an omni-chain, account concept. These that are being actively researched and have no clear answers yet, I would say, like from any team in the world. Now, this is where we think that some interesting breakthrough will happen, and we believe that we will be leading the way on that front. So, like, it's kind of a building an operating system on top of all the blockchains, not just for message passing, but for kind of an ultimate user experience to interact with any application has states, has storage, has compute stored across and located across all the different chains. So yeah.
Interesting. And do you see that kind of abstraction layer expanding past non-EVM chains? So, Cosmos, Solana, etc., or it being mostly in the Cosmos and Ethereum spaces?
Yeah, absolutely. So, I think every blockchain should be part of that universe, though some of them may be expanded too quickly, some of them might be slower. But for example, we will be supporting Aptos like on day one. So yeah, definitely. It's just not only just for EVMs, for sure.
Lots of Aptos hype these days. We're interested over here at LI.F.I in Aptos. That is all I'll say. Um, so we have about 15 minutes left. Would love to talk about what is already being built on Celer IM, and then maybe tell us more about what you're hoping is going to be built on Celer IM. But we'll start with the first Q. What type of dApps are already being built on Celer IM?
Yeah, sure. So we can go over some categories, and we can name some examples. First of all, Li-Fi, yay, you guys are using or considering using Celer IM to kind of enabling cross-chain swaps. So yeah, that's definitely a great use case. And similar to Li-Fi, there are a bunch of other cross-chain swap use cases out there. They're essentially enabling you to swap token A to token B from any chain to any chain, really, with efficiency, right? So that's definitely a great use case. And the good thing about Celer IM is that you can use it not only just to integrate Celer C bridges liquidity, you can actually use it and use something called a counterfactual contract creation to integrate all the different bridges liquidity as well. So it's not really just exclusive to Celer C bridge, although we use the example of Celer C bridge, but it's actually very generally applicable to kind of different liquidity sources. Yeah, sorry.
Oh, I was actually what bridges were next for Celer IM was going to be my follow-up question here. Are y'all in talks with any single bridge to build inside of Celer IM? I don't know if you can talk about it.
I would say it's not really about kind of a Celer IM integrating with bridges. It's more about like solutions like Li-Fi can actually integrate IM with a different bridge than Celer C bridge. And there's no kind of a support needed on Celer IM or that particular bridge. So it can be done like all in just one transaction. There's no dependency there. So let's say if you want to use a different bridge, Celer, for example, and also use Celer IM to do this A to B swap, you can do that, no problem. So it's fully compatible with all the other solutions. So yeah, continuing on the DeFi ish space, as we mentioned, there's pancake swap that are expanding into multiple different chains. The first stop that they use is to use Celer IM to do reward claims. So if you do go to Pancake, Ethereum side today, you stake certain LP tokens. The reward you get is actually directly on BSC, and when you claim that reward, it's actually a cross-chain function called by Celer IM. So that's really cool, and in production already. And there are also cross-chain futures like MUX. We're also talking and working with a few others that are launching pretty soon. The good thing about the cross-chain swaps is that you can actually kind of deposit liquidity anywhere, without actually making the bridge. Because if you're bridging the liquidity, depositing into, let's say, certain, MUX or like GMX or something, you actually need to pay the bridging cost for bridging back and forth. But you can actually just lock the Ethereum, or your collateral on your own home chain and start trading on the destination chain. So this is a pretty straightforward use case. And you can also build lending protocol. We're working with Atlantic's lending protocol, where you can just lend, kind of provide liquidity on one thing and borrow out the liquidity on another. It of course involves a cross-chain collateral settlement and some nuances, but this is definitely possible. So this is a kind of a bunch of very simple DeFi use cases. There are also a bunch of derivatives use cases. It's very similar to perpetual swaps in general, because you're essentially providing liquidity and creating virtual liquidity tokens on the destination chain. So So there's also a lot of gaming apps. So for gaming apps, we work with Audiverse to kind of enable their cross-chain NFT solutions, and LI.F project to enable things like Meta Apes, which is a Binance application sidechain gaming project that enables cross-chain NFT. We enable two different type of NFT bridges where you can bridge existing NFT to other different chains, and also create NFT that is naturally multi-chain, that you don't have a home chain for that NFT, but just can kind of naturally burn on one chain and create the same. So for example, it's using that. For NFT, there's always this NFT marketplace. We're working with NFT Trade to build out cross-chain NFT purchase mechanism where you can just purchase an NFT you like from wherever you are, on the marketplace that they deployed on certain chains. So and there is also governance. We cannot kind of omit governance. We work with FutureSwap, OKey, and all the other different solutions to enable cross-chain governance to pass governance calls so that it's truly decentralized. Many people don't realize this, but if you're a DAO, but you're using actually multi-sig to kind of carry out cross-chain governance, it's not exactly a strict decentralized DAO approach, because certain multi-stakeholders actually decide the governance decision on certain chains. And we're also working with a couple of different wallet providers who are thinking about this kind of new account abstractions. And that's kind of a longer conversation, I would say. So yeah, definitely, this is happening on all fronts, like from DeFi, from gaming, from governance, or from just generally passing messages for some interesting use cases, like distributing and airdropping tokens to multiple users cross chain. So yeah, these are definitely all also possible.
Yeah, that's great. From gaming, futures, cross-chain governance, Celer is really connecting all blockchains, every dApp, every asset, every user. Maybe I should get that on a T-shirt or a cap. I want that. If there's no Celer merch with that, I'll definitely want something like that. Well, that's a lot of detail about a lot of cross-chain plans and features to have ahead. But I just wonder to be a little bit more specific with maybe the next couple quarters just coming up. What lies ahead that's already planned, maybe on your roadmap that you're looking to introduce to your users and partners?
Sorry, my networking connection just broke, so I completely missed the previous question until you said
Yeah,
the last sentence. Sorry.
no worries, no worries, no worries. I was just wondering, a lot of detail has been shared, and loving this convo, by the way. But I was wondering if we could hone in on maybe what's coming up in the next couple of quarters for your users, for your partners. What features and what's planned for Celer next over the next couple of quarters?
Yeah, for sure. So there is this kind of a common ecosystem expansion for sure. More chain supported, more token supported. In terms of the asset bridges and also IM, and of course more use case supported. There are a lot more developers building, and we're helping them to build using Celer technology. So this is a really big focus, and we are kind of expanding the ecosystem because Celer is a functioning system, and a lot of developers are already benefiting from it, and building great use cases on that. So we're definitely kind of pushing on that. But at the same time, on a kind of a breaking new ground, there are a lot of interesting things that are happening in the bridging space, and on the cutting edge side of the research, we're also contributing to the ecosystem on the very, very cutting edge of the research. involving zero knowledge and many other things like account abstraction. As I mentioned, this kind of operating system concept is also extremely interesting.
Yeah, that's great. Really interesting indeed. I concur with that for sure. Well, we come into the end of our conversation today, and usually when we get to the end, I'd like to ask our guest, and today you. So, if there's any last thoughts that you'd like to share with the audience here today, with both our communities combined. So, any last thoughts or things maybe that we haven't spoken about that you were hoping we'd speak about? Now's the opportunity to mention.
Yeah, I think we had a really fun chat and covered most of the topics. Right now, I just don't have anything immediate to share. But for the community, if you haven't used Li.Fi and if you're considering doing cross-chain bridges, try it out. It's awesome.
100%. Try it out with Seabridge. Well, thank you so much for your time, sir. We really do appreciate you taking time out of your day to hop on this installment of our A and B series. Well, that's all that we have today from Mark, Arjun, myself. Thank you for tuning in. Make sure to read the A and B on our blog if you have not read that yet. But this has been a pleasure with Celer, talking about connecting all blockchains, every dApp, every asset, every user. Until next time, cheers, everybody.
Thank you, guys.